Okay, on your periodic table, let's remind ourselves of the number of valence electrons and the oxidation numbers for all of the families with predictable charges on here. So what I'm talking about in that is anything in the S and P sublevels. So in group 1, this is group 1 right here, how many valence electrons do we have? One valence electron. And then group 2 has how many valence electrons? Perfect. Now, something that often gets mixed up is the numbering from here on out. Okay, so 1 and 2, easy, obvious. The rest are also easy and obvious, but we skip over groups 3 through 12 so often that we sometimes forget that they are actually numbers 3 through 12. So if I ask you about group number 3, this right here is group number 3. And this is group number 4 and 5, 6, 7, 8, 9, 10, 11, 12. We skip over all of those because that D block does not have predictable valence electrons. So then by the time we get over here in the group with boron and aluminum, what group number is this? 13. And group number 13 has how many valence electrons? 3. So because it has 3 valence electrons, people often call it group number 3, but you need to recognize that it's actually group 13, and that just comes from counting the columns across the periodic table. Alright, then after 3 valence electrons, we have 4 valence electrons, then 5 valence electrons, then 6 valence electrons, then 7 valence electrons, and then we say 8 valence electrons, but keep in mind that we moved helium over to the other side. Helium does have 2 valence electrons, so that's kind of why we put it here. It is over on this side on the normal periodic table because it's stable. So either way, it's going to be an exception whether you've moved helium or not once we put our oxidation numbers in there. So as a reminder, your oxidation number simply means the charge that something gets from gaining or losing electrons. So in group 1, do you remember the oxidation number that it has? +1. And group 2 has +2. And group 3, sorry, I said group 3, group 13, +3. Group 14, ±4. And then group 15 with 5 valence electrons, -3, and then -2, and then -1. And then these guys have no charge. So here's why helium really is over here, is because, yeah, it has 8 valence electrons, or this group normally has 8 valence electrons, and helium does not fall into that category, but helium is stable and has no oxidation number, because the oxidation number comes from the amount of electrons that something gains or loses. Why would these guys not have any oxidation number? Why don't they gain and lose electrons? Why don't they really need to add or subtract any? I heard because they're stable. So because the noble gases are already stable, they don't need to gain or lose electrons in order to become stable. So they're not going to, because if they were to gain, if they're already stable and then they gain or lose any, then they become unstable, and that's not what they want. So the whole purpose of an atom gaining or losing electrons is to become stable, which means full valence shell, which for most elements means 8 valence electrons, but for some it means 2. And helium is one of the ones that only needs 2. So again, it doesn't really matter where you think about helium being on the periodic table, as long as you remember it's pretty much the exception to a lot of rules, similar to hydrogen. So far, so good? Okay. If we were to describe how, let's pick magnesium. So number 12 right here, magnesium. How does magnesium get a +2 charge? What happens to it that causes that charge? Good, it loses 2 valence electrons. And so if magnesium is number 12, so I'm going to write this out so we're like following along. So magnesium as an atom, we know that magnesium as an atom would have 12 protons. You don't necessarily have to write this on your periodic table, but just somewhere so that you're following along. So if it's a magnesium atom, it has 12 protons. How many electrons would it have as an atom? 12 electrons as an atom, and that makes it neutral. What we know is that magnesium is eager to lose 2 electrons, which would give it a +2 charge, so I would still have 12 protons, So magnesium ion has 12 protons because it's still magnesium, and every time if you're talking about magnesium, it would have 12 protons. It would want to lose 2 electrons so that it's dropping down to the next lowest or next highest energy level. And if it lost 2 electrons, how many total electrons does it have? 10 electrons. And that would give it a +2 charge. So the way that we would write that is Mg with a +2. Now if we look at this kind of in isolation, if you have 10 electrons, what atom has 10 electrons? Neon. So neon is right here. Neon has 10 electrons. And so when magnesium forms an ion, its electron configuration is going to look like the electron configuration for neon. Since magnesium's goal in becoming an ion is to become stable, what it's going to do is try to replicate the electron configuration of something that's stable. And all of the atoms or all of the elements are going to have a specific noble gas that they're trying to look like, a noble gas configuration that it's trying to attain. Does that make sense? Okay, so it's trying to look like neon with 10 electrons. Let's pick a different one. Let me use a different color. So instead of doing magnesium, let's do, I don't know, nitrogen. So if I am nitrogen as an atom, how many protons do I have? Okay, so I have 7 protons. How many electrons would it have? 7 electrons. Again, that would be neutral. If I am nitrogen as an ion, how many protons do I have? 7 because I'm still nitrogen. How many electrons would it have? So when nitrogen wants to form an ion, it's going to form a -3 ion, which means that it has 3 more negative charges than positive charges. So how many total electrons? 10. Okay, so 10 electrons. And we just talked about this a second ago. If you have 10 electrons and you're an atom, who are you? Neon. So nitrogen, as an ion, would also look like neon for its electron configuration. That is the noble gas that it is trying to attain. This is different than the noble gas shortcut for the electron configuration, because for the shortcut, it always has to be the one that you passed through on your way. But in forming an ion, it could be something that comes before that noble gas, or it could be something that comes after that noble gas. It just depends on if it's gaining or losing electrons. Do you see that? Perfect.